So today we're talking about the steel industry. What's the link between scrap and steel?
Steelmaking starts at the scrapyard, and scrap is the most important raw material for steelmaking. That's why we are offering solutions to help steelmakers improve their melt shop efficiencies by cleaning incoming scrap of impurities. Our long-term friend and steel expert, George Bond, can explain this interface as he knows both sides of the story. But let's ask him directly. Hey George, why is scrap quality so important for steelmakers?
It's a good question. But every steelmaker understands that scrap quality determines the quality of the steel and the company's profitability. Scrap, in reality, offers 3 physical attributes. Each has the potential to impact positively or negatively steel performance. The first is metallic Fe content. This determines production rate and liquid steel yield. Secondly, chemistry. Chemistry determines the quality of the steel you can produce. It avoids grade changes and minimizes production delays. The third attribute, bulk density, impacts power consumption, charging speed, and tap-to-tap times. Scrap is 70% of an electric arc furnace costs, and quality control is limited to scrap blending based upon visual assessment. Think about that. Most EAF plants will spend $300 million every year on raw material, and all they get for that is a visual assessment based upon a simple, subjective written description. It's not surprising that the technical and fiscal volatility in the steelwork is abundant. I can't understand why a steel plant would risk $300 million without knowing accurately what they're putting in the furnace. And in 2020, having sensors that measure important attributes like metallic Fe, chemistry, and bulk density are available. Why wouldn't people measure the quality of the scrap? With this level of control, the plant can minimize all the physical and technical volatility of the operation. The potential for scrap quality to improve steel plant performance is an untapped opportunity for every steelmaker.
Heiner, as George explained, we have different solutions to help the steel plants overcome their problems. Can you make us more familiar with those solutions?
Yes, let's start with our HMS cleaning. In 2019, roughly 53 million tons of scrap were consumed in the US, and roughly 20% were sheared scrap, so-called HMS qualities. Hence, we are talking about more than 10 million tons per year. With our HMS cleaning, we help steelmakers to clean incoming HMS from impurities which can be fine and also magnetic dirt, free debris, wood and stones, non-ferrous metals.
And why should steelmakers do this?
Even the best steelmakers cannot produce liquid steel from dirt and debris. Cleaner scrap has significant advantages. Increase of the liquid yield, reduction of the tap-to-tap time, reduction of the specific energy consumption, reduction of the wear on electrodes and refractories, reduction of the lime consumption, reduction of the environmental burdens, and reduction of the amount of slag.
And speaking in numbers, what can the system process and where should it be installed?
We have systems from 50 to 300 tons per hour on a constant basis. Each system is customized to the specific needs of the steel plants. The best place is on the steel plant's scrapyard to run all incoming HMS over the system, also as a kind of quality control.
About which annual quantities are we talking?
The latest system is processing roughly 600,000 metric tons per year. Even more is possible if requested.
What does SiCon make different and unique?
Well, we have carefully analyzed the expectations of steelmakers as well as the obvious problems conventional older systems have. no separate feeding zone, no material acceleration, no or insufficient screening zone, insufficient magnetic power. On the product pictures from a conventional system, you can see how much dust and magnetic dirt is still in the clean scrap. That is not what steelmakers need. Such systems are a waste of money.
Can you be more specific, Heiner?
Of course. The SiCon HMS cleaning consists of several components. Feeding zone by a heavy-duty vibratory conveyor, acceleration zone, screening zone with a screen design which cannot block, magnetic separation. Usually, we work with our powerful MagSpin permanent magnet. Even in 3-shift operation, no drop of magnetic power and an intensified agitating zone for a better cleaning. Separation of fine material, so nothing is lost. And if requested, we also process the residue fractions if the steel plant wants to keep the value in-house.
That sounds very technical, but what is the commercial benefit? What's a steel plant's motivation to invest in such a SiCon HMS cleaning?
Very good question, Vicky. George, as an old Steelworks fellow, can you maybe explain this to us?
Cleaning scrap creates additional profitability and ensures the long-term operational security. Scrap-based steelmaking globally achieves liquid steel yields ranging between 86 and 91%. There are some overachievers, but they are exceptional operations, and equally there are a few underachievers hitting 83% liquid steel yield. Independent controlled trials using an induction furnace to melt 1,000 kilograms of clean car scrap produce a liquid steel yield of over 99%. I appreciate small laboratory trials are not reflecting industry, but they do highlight the potential benefits from high quality scrap. This trial inspired operational material trials on 4 of the major grades of scrap. These trials, all of the contaminants were identified and how to remove them cold by mechanical processing. Processing to a higher quality is possible with current technology. The motivation for improving scrap quality is simple. Processing scrap cold is far less expensive than processing it in a furnace. SiCon have built pre-melting cleaning processes for HMS, and they chose HMS because it represents 50% of all globally traded ferrous scrap. The SiCon HMS cleaning concentrates the metallic Fe content in HMS by 8%. This simple step created additional steel plant profitability, recovering the investment within the first year. And now it's a closely guarded secret, so getting to see it is not as easy as everyone would like. Interestingly, the 8% contaminant removed was 75% non-metallic and 25% metallic residues, non-ferrous metallic residues. The recovery of the non-ferrous metal residues created 2 additional benefits. The first one, the additional commodity sales more than covered all of the cleaning plant operating costs. And secondly, when the scrap was melted, the melt copper was lower. Scrap is not processed well enough to remove the volatility from scrap-based steelmaking. The steel sector needs an intermediate step between the merchant or trader and the furnace. The motivation to improve scrap quality is simple. It will create the opportunity to determine steel quality in the charging basket. The scrap charge should have the density which optimizes furnace performance. Concentrated metallic Fe, no more wasting time and power melting contaminants. The chemistry must be measured and controlled to ensure EAF products can enter the high quality long product market.
Thanks, George. If I were in charge of a melt shop, I'm sure I would have such an HMS cleaning system, as this seems to be the most important cost-reducing trigger there is. Thanks, gentlemen. This seems to be clear for me now. Heiner, but what about scrap tuning? What is the difference?
Scrap tuning was developed by our team to encounter the increasing problems from impurities when using shredded scrap. 33% of the consumed scrap in the US in 2019 was shred, more than in any other part of the world. We know from important consumers that the copper content in shred is increasing from year to year. Let's have a look at this chart, which is based on real figures. This is causing problems. Maybe not for some long steel producers, but definitely for flat steel producers. This means they need to be increasingly careful when using shred or need to compensate quality deficiencies by using expensive DRI or HBI.
George, why does the copper content increase steadily?
In 2007, the average melt copper at European electric arc furnaces was 0.32%. In 2018, it had increased to 0.37%. A significant increase in only 11 years. In 2015, Cambridge University undertook a study, Sustainable Engineering Materials, and one of the conclusions was that the increased use of copper within component manufacture would result in melt copper from scrap-based steel making would reach 0.5% by 2030 and 1% melt copper by 2050. It is a popular misconception that the rising copper content is an inherent issue within the steel and cannot be recovered by mechanical processing. If you need proof of this, then you should have a little think about how you see scrap. Most products from steel have a life of between 5 and 80 years. So if we took an average of say 30 years and then took a look at what steel making was going on 30 years ago in 1990, we would see 70% ore-based steel and 30% scrap-based steel. The ore-based steel will have a copper content of 0.005%, and the melt copper from scrap-based steel making will be 0.3%. If we take an average, I'm not saying that's a calculated accurate average, but if we take a general average, it would be 0.1 melt copper. If it's now 0.37 and the steel is considered to be 0.1, then the only answer to the problem can be that the copper is free and recoverable. Consumers are demanding smarter products, and this will ensure the use of copper will continue to rise in manufacturing. The Cambridge University study concluded that if scrap processing technology does not grow at the same rate as copper in manufacturing, then melt copper will continue to rise.
George, may I add one more important point? Scrap processors usually run their shredders output focused and not quality focused. Would you agree? You were managing director of a company with a mega shredder in the UK.
I would agree. In scrap processing, you have two opportunities to create wealth: volume or quality. The sales value difference between the three shredder scrap grades is not great enough to create a wealth opportunity. A mega shredder operator has only one wealth opportunity: volume. Steel plants and scrap processors would mutually benefit from producing a scrap quality specification based upon value-adding attributes to the steel production process. Adding value to the supply chain delivers a mutual beneficial outcome. This would create a more quality-based focus. A final point: I started work as a melt shop metallurgist. At every meeting, I would identify how every melt shop problem could be traced back to the scrap. Scrap quality was limiting the steel plant's ability to develop new products. The outcome from my tenacious debating was they bought a scrap business and told me to fix the problems. I have known the solutions to prepare scrap with concentrated Fe, managed chemistry, and a density of scrap to achieve single basket charging, and I've known this for 30 years. The technology is simple, but the commerce of change, with a perceived threat from the supply chain, has shackled scrap processing development. Break the shackles. SiCon have taken innovative steps to develop the technology which resolves the problems we have discussed.
Gentlemen, now what does scrap tuning do?
Scrap tuning is our answer to worsening and unstable qualities of shredded scrap for steel makers. Scrap tuning is a compact system for installation and operation inside steel plants in order to controlling the incoming quality, separation of remaining fuzz, fluff or magnetic dirt, separation of remaining liberated wire, separation of remaining meatballs and other copper-rich scrap, controlling of the final quality of the clean shred, and automated mass balances. At the end of the process, we are at constant level of copper ranging from 0.15 to 0.20 in the final product. No surprise, no risk anymore for the melt shop.
Sounds logic, but where is the benefit for steel plants here?
The great thing is that usually the total cost means CapEx and OpEx are covered by the metal revenues. If we also consider the positive metallurgical effect, the payback can be below 1 year.
Sounds logic to me. Why don't more steel makers do this?
That's a good question. Using DRI HBR pig iron seems to be easier, although more expensive and less energy efficient. So far, only a few steel plants have realized the total potential of using clean shred and the associated cost savings. With more sensitiveness to energy cost and reduction of CO2 emissions, any steelmaker will explore the real value and possibility of using more shred after cleaning it to be independent from single suppliers. It's a question of time.
Do you have evidence for this?
We have developed the EcoScan Online exactly for this. It analyzes the shred in real time.
That's really exciting. How does EcoScan work?
May I introduce our colleague Christian to answer your questions?
Hello, Christian.
Hello, Vicky. Hello, Heiner. Thank you for the invitation. But first, let me introduce myself to the audience. My name is Christian Roth and I work as a project manager at SiCon. I am the expert for the EcoScan Online, which I would like to present to you right now. The EcoScan Online is our online scrap analyzer based on X-ray fluorescence technology. It is integrated into a radiation-proof housing and is usually positioned on a stacking conveyor after the handpicking station in a shredder plant. It measures online the chemical composition of the produced scrap and allows you to get an impression of how good, in means of quality, the scrap is that you are using and producing. It is capable to measure elements like copper, zinc, manganese, chromium, nickel, and more. Due to the amount of data the system generates, it even allows conclusions about the condition of the shredder, weaknesses of the process, and the productivity of the hand sorting station. The data and reporting system is designed in such a way that certificates can be generated either for a specific time period or for troughs of scrap metal, which then can be added to sold scrap later. This is completely customizable. Through direct data transmission, the system can also inform the shredder operator, if limit values are exceeded, to use other input material to maintain the desired composition in the batch. This is an important step to be able to supply, for example, steel plants with larger quantities, because you are able to prove your quality on your own. Thank you for your attention. Hereby I close the webinar for today. I hope you enjoyed it. For further information, please contact us directly. We would be happy to assist. Stay safe and goodbye.